Hey everybody, it's Mrs. Harris. I'm going to do the slope and perpendicularity homework with you. So first of all, it starts off with just given slopes here, and it says give the slope of a line that's perpendicular. So you guys should know that from the video, when you see perpendicular, that their slopes have to be, I believe he uses the language negative reciprocal. You might also hear the language, that's the same thing as opposite reciprocals. So negative reciprocal and opposite reciprocal, those are kind of interchangeable language. I always use negative reciprocal, and then honestly, most of the Victor teachers use opposite reciprocal. So you're going to hear both though, and you should know both. So what happens here is you want the slope perpendicular to it. What you're going to do is you are going to flip it. That's what the reciprocal means, right? Is flip the fractions. So flip the numerator and the denominator. And then this opposite or negative means to switch the sign. So if it's positive, it becomes negative, and vice versa here. So same thing here. That word negative doesn't mean it's always negative. It means switch the sign. So we should easily be able to get these. This should be negative 3/4 perpendicular. The perpendicular to this, flip it, would be 7/3, and it has to be positive. This one's a little tricky. Think of this as 4/1. If you flip that, that's 1/4, and then that's positive, so my answer has to be negative. This one, flip it, that would be 3/1, which is just 3, and then that one's negative. This one is positive. And same thing here. What is 1 actually? 1 is actually 1/1. So when you do the reciprocal of that, that's the same, right? The reciprocal is 1/1, and we just need to make that negative. So the answer here should be -1. So those ones were pretty easy. Here they want to know what's perpendicular to EF. So eventually it's not always, this homework's all on perpendicular, but eventually you're going to be mixing in with parallel. So you got to be a little careful. Whenever I see perpendicular, I always just circle that and I make a note to myself. Okay, we want to take the negative reciprocal. So first of all, I'm going to find the slope of EF. So to find the slope of EF, I'm just going to use my slope formula, which is the change in y's over the change in x's, right? Or rise over run. So we should be pros at this. I'm going to do change in y's would be -2 minus 4. These are the y values, -2 and 4. And I'm just subtracting them, -2 minus 4. And then same thing in the denominator, 3 minus -1. You should get a -6/4, which always reduce if you can. -3/2. Now that's the slope of EF. So I want to know what is perpendicular to that. So notice they put this as a choice, as a trap. So perpendicular to that, the slope perpendicular, this is the symbol for perpendicular, would be 2/3, right? And opposite reciprocal. Flip it and switch the sign. This should be choice 1. Okay, number 3, there's honestly a lot of different ways to do this one. If you had graph paper, you could plot it and probably easily figure it out on graph paper. I'm going to do it algebraically for this key. So if the slope, we want it to be perpendicular to, so I want the negative reciprocal of -2. So first of all, we need our slope to be what then? Hopefully you can get this on your own. We want our slope to be +1/2. So that's what our perpendicular slope is going to be, +1/2. So we want this line segment to have a slope that is 1/2. So what we're going to do is I am going to use my slope formula, which is the change in y's and the change in x's again. So I'm just going to do a minus 9 is my change in y's. And 7 minus 3 is my change in x's. And I know that I need to have that equal to, I want it to be equal to 1/2, because I want it to be equal to this perpendicular slope, okay? So now you can solve this however you want. I think most of you might cross multiply. So this would be 2k minus 18 equals 1 times, what's 7 minus 3? That's 4. So this would be 2k minus 18 equals 4. So 2k is 22, which means k is 11. Again, if this was a test or whatever, I would use another strategy to make sure I'm right. I would then plot these 2 points, make sure it looks like it has a slope of 1/2, check it out. But yeah, that's the algebraic way to solve that one. You could easily do that on graph paper, like I said. Okay. Which would be the slope of a line perpendicular to this line? We want it to be perpendicular to this line. Well, let's first figure out the slope of this line. So I'm going to pick 2 points where it crosses really nicely. Right here, it crosses at an exact point, and right here. So it looks like rise over run. I'm going down 2 and over 1, 2, 3, 4, 5, right? So the slope of this line appears to be -2 fifths, -2/5, the rise over the run there is. Remember, on a graph, you want to be doing rise over run if you're doing slope. So if the slope of this is -2 fifths, then what do I want my slope to be if I want it to be perpendicular? Well, we want the perpendicular slope, that's my little perpendicular symbol, to be the reciprocal and then negative, right? The opposite sign, opposite reciprocal or negative reciprocal. So if that's negative, oops, oh geez, I just made a mistake. If that's negative, then I want my reciprocal to be, I want my opposite reciprocal to be positive. So the answer there should be 2, 5/2. Okay. This one's going to have multiple answers. I'm going to just plot the line, draw the lines first. So they want us to draw a line that's parallel and perpendicular. So parallel line, I'll do in red. So first of all, let's figure out the slope of this. The slope of this line given, I'm going to pick 2 points here that cross perfectly. The slope of this line looks like it's up 2 over 3. So the slope is 2/3 based on my rise over run count. Therefore, if I want to plot a parallel line, we obviously have to have the same slope. That should have been last lesson that you learned that. So I'm going up 2 over 3, which is the same thing as down to left 3, because that would be so equivalent. So now here is my parallel line. My parallel line is then red there. What is it? Just wants 1 point on it. I guess I'll pick this point, 1, 8, it looks like. So you obviously could have picked any of the points on that line. I just chose 1, 8. So there's multiple answers to that. You could have picked -5, 4. That's another one. -5, 4. Yep. You could have picked -2. You could have picked -2, 1, 2, 3, 4, 5, 6, -6. You get the gist. There's lots of answers. Okay. Oh no, you can't pick -2, 6. That is point C. Okay. Next, I'm going to do the perpendicular one. So pause the video and you should be able to figure out what you want your slope to be. If these slopes have 2/3, we need it to be perpendicular. So what do we want our slope to be? It should be -3/2. So I'm going to start at point C since we wanted to go through point C. And I'm going to go down 3 over 2. Down 3 over 2. I'm just going to continue this to get the best picture I can, except I counted wrong. Man, I have a weakness of counting boxes on the grid. It's not pretty. Okay. And then, yeah, there it is. So notice if we, oh my God, I messed one up here. Yeah. Okay, hopefully you can count boxes better than this. I think it's gonna try to go too fast, or I don't know. I don't know. I can't count. Okay, here is my line. Here's, you can notice that looks perpendicular. It's the 90-degree angle. So we want to point on this. I'm just going to pick this one. That's 0, 3. That's an easy one. So 0, 3 is a point on that. You could pick any of them on that green line, though. All right, moving on. Ooh, don't have to print or plot points anymore. Okay. Are these perpendicular? So if they're perpendicular, we know their slopes would be opposite reciprocals. I'm going to do this line in red. So I'm going to do the slope of, notice my notation, I'm being really neat. I want my slope and I'm putting in a subscript that's called what I'm finding the slope of. I'm finding the slope of AB. So pause the video and find the slope by yourself. Okay, I got 5 is my answer with the change in y's over change in x's. So check your math if you didn't do that right. So now I'm going to do CD. You guys should do the same. Okay, this shows how important it is to reduce. So you get -2/10. So if you look at these two, you might not see that they're opposite reciprocals right away. But if you reduce this, remember you can do that right in your calculator, you get -1/5. So now we should be able to recognize that these are definitely opposite reciprocals. So your explanation should say, yes, these are, AB is perpendicular to CD since slopes are opposite or negative reciprocals. I know the teacher uses negative reciprocals, sorry. Okay. I was gonna say that in your explanation, a lot of students write, yeah, the lines are perpendicular. They'll say AB is perpendicular to CD since they are negative reciprocals. So you can't just say since they are negative reciprocals, because that would indicate the lines are negative reciprocals. That makes no sense. So you need to make sure you have that the slopes are negative reciprocals. That seems obvious, I guess, but your explanations, a lot of people don't write that, and then it doesn't seem, that doesn't make any sense without it. So the slopes are opposite reciprocals. Okay, last one. We're gonna do a little proof here on this last one. So we're gonna plot these points. I'm gonna pause it. Okay. So it wants to know if this is a right triangle. Well, if it's a right triangle, then it's gonna have a right angle, right? So if it's a right triangle, it has to contain a right angle. And this is what we're trying to see is, does this have a right angle? So my first question to you is, where would the right angle be? If this had a right angle, which one of these would be a right angle? And hopefully you can see that it would be G if that is a right angle. The other two aren't even close. So the question here is angle G a right angle? How are we going to tell that? Well, we're going to test the slopes of the two segments that form angle G. So what two segments do we need to test? And we're going to see if their slopes are negative reciprocals of each other. And that is going to prove us whether that's a right angle or not. So I'm going to do the slope of EG and I'm going to do the slope of GF. Notice exactly what I'm finding. This is huge because this is a little proof. So the reader should be able to tell exactly what you're doing. I'm going to find these two slopes. I'm going to see if they're negative reciprocals. So pause it and find those two slopes for me. You should be able to do that part on your own. Okay, here's what I got for my slopes. So you can see neither of these can be reduced. So are these opposite reciprocals? The answer is no, or negative reciprocals. So the first thing I'm going to say is EG is not perpendicular to GF since their slopes, remember, add in that, slopes are not opposite reciprocals or negative reciprocals, same thing. So thus, angle G is not a right angle. And then I don't know if he used this in the video or not, but this is important to note that your math teachers in the future might use this, or science teachers even. These three dots mean therefore. So since this is a little proof, I'm going to do a concluding statement, and that's my little therefore statement. So therefore, I'm just going to state the answer. This triangle, EFG, is not a right triangle. So there's my little proof. Okay, if point H lies on EF such that GH is perpendicular to EF, GH is perpendicular to EF, that's the key. What is the slope of GH? Okay, well, we're gonna have to find the slope of EF, right? And then they're gonna be negative reciprocals. So let's do EF first, because we have those points. So the slope of EF, pause it, do it. Okay, I got that the slope was negative 5/3. So the opposite reciprocal to that, or the negative reciprocal, is going to be the slope perpendicular, which is going to be the slope of GH is what they want. Sorry, I'm just going to fix that notation. So the slope of GH is then the negative reciprocal of negative 5/3, which is 1. Slope of GH would be positive 3/5 should be your answer. Negative reciprocal. There you go. Good work, guys.